I do have a copy of notes for you all, which I'll give you, and you can make copies of it amongst yourselves. Now let's jump in with a new topic today, the last topic of the year. We should be done with this in 3 weeks. I'm not sure what we're going to do after that, but we'll figure it out. Cross that bridge. So limits. We want to talk a little bit here today about limits. And I'll give some notes, and then we'll do some problems. So we'll start with some notes, and the notes are a little bit theoretical. They will make more sense once we do a problem, but we need to get the theory before we move into the practice. So limits, you need to really have only 3 things in your mind when you think about limits. The first one is, when we think about limits, we're talking about what happens to a function. And when we say function, we mean y values. So what happens to a function? What happens to the y values when x approaches a number? There are really a couple key words here. The first is approaches. When we're talking about limits, we're saying what happens when I get close, not when I touch the actual value. That's a huge distinction that a lot of us forget to make. I'll be very specific. This does not mean what happens when x equals a number. What I'm talking about is this, approaching a number. I am not talking about this. Approach, not actually touching the number. Now, the notation for a limit is the following. We say limit, we abbreviate limit, excuse me, as x approaches a number. C is just a number, 3, 5, 10, of this function. So in words, this means the limit as x approaches c of f of x. So the limit as x gets really close to this number of f of x. In English, it is what happens to y as x gets super close to c. I know that seems very casual language, but that's actually what it means. It's often helpful to think about math in some very basic casual language. Now, we call a limit like this a double-sided limit. And here's why we call it a double-sided limit. If you think about this chair being here, I can either approach the chair from this side, right, or I could approach the chair from this side. There are, in other words, 2 sides to approaching any point or any value. Hence, we call this a double-sided limit, because we're asking what is happening as x approaches the number from both sides. If you think about a number line, here's -1, here's 1, here's 0. I'm asking what is happening as I approach from the right and as I approach from the left, from both sides. This is called a two-sided. That is in sharp contrast That is in sharp contrast to the single single-sided limit. Single-sided limits. The first one is limit as x goes to c. Sign here. Don't think of it as a negative though. Don't think of it as a negative. Think of it as meaning left. So this is a limit as x approaches c from the left. So in words, the limit of f of x as x approaches c from the left. So thinking back to our number line here, 0, -1, 1. This is coming this way. Brianna. Yes, it is. The other option, of course, is if there was a negative, there has to be a positive. So limit as x approaches c from the positive. But don't say positive, say right. This negative indicates left. This positive indicates right. And in words, this is the limit of f of x as x approaches c from the right. This way. Single-sided limits. Right now this seems very theoretical. We'll do an example that will formalize it. In order to do the example, let's go to page number 6, level 5. Page 6, level 5. Okay, so page 6, level 5. So right here, bottom of the page. And there's just a bunch of like limit problems here. These are graphically, and we'll just work through them, and I hope through the process what I discussed will become a little more formalized. So limit as x goes to 6 from the left. So the way I attack these problems is very similar. The limit as x goes to 6. So I'm going to take my graph and draw a little wall here at 6. And all I am asking is what is happening as x, here's the x-axis, so as x gets close to 6, here's 6, the wall, from the left side. Okay, I do not care about this right side. Nor do I care about what happens at the wall. Because remember, limit is getting close, not actually making contact with the wall. So we want to know, as we approach from the left, what happens. So start on the left, here's the left, keep on going, getting closer and closer to the wall without touching it. The y values over here are getting bigger and bigger and approaching 1. It never touches 1, that does not matter, because we don't care what happens at the wall. All we care about is what is happening as I get closer to this wall. So the answer on this one is 1. Questions? Okay, let's try number 2. So limit of f of x as x goes to 6 from the right. So all I'm saying is, here's the wall at 6. I do not care at all about the left. Just going to cover it up. All I care about is what is happening as x gets closer to 6 from the right. Here's the right. As x gets closer to 6, y seems to be getting closer to some number up here. What is that number? That number is 1. I do not care what happens at the wall. I simply care what happens as I get super close to the wall from the right side. That will be 1. Questions? Brianna, go ahead, please. Yeah, so limit has no effect on the shading or unshading of the circle, because we're just getting close to that point, not actually there. Okay. Number 3, the numbers kind of got messed up. It's on actually page 7. Number 3 is kind of weird, but limit as x goes to 6 of f of x. So again, this is the double-sided limit, and this allows me to bring in a rule that we need to know. If the limit as x goes to, I'll do it in theory first, then a number. So the limit as x goes to c from the right equals a, and the limit as x goes to c from the left equals a, then the double-sided limit equals a. So if the limit from the right and the limit from the left both equal the same thing, then the double-sided limit equals that very thing. Let me now say it specifically to this example. The limit as x goes to 6 from the left is 1, and the limit as x goes to 6 from the right is 1. Then the limit as x goes to 6 from both sides, if you don't have any plus or minus, that means both sides is also equal. 1 and 1 equal each other. This also equals 1. Questions? Look, number 4. F of 6. Number 4. F of 6. F of 6 means, and again, this is what the point I was trying to make earlier. F of 6 means what happens when x actually equals 6. What happens when x actually equals 6? In other words, what happens at the wall itself? What happens at the wall itself? Well, when x is 6, the function is undefined. There is no y value. F of 6 is undefined. F of 6 is undefined. Now, this brings us to the next rule. If, now I'll do it in theory first, then specific example. If the limit, the double-sided limit, does not equal f of c, in other words, if the limit doesn't equal what happens when I actually touch the point, then f of x is not continuous at x equals c. If the limit does not equal the value of the function, then the function is not